Hi, everybody, and welcome to today's episode of Working from My Basement. My name is Chris Bauman with Mizar Imaging, and today we're going to talk about some of the sample chamber options and some of the sample prep considerations that will be used when imaging with the Tilt light sheet imaging system. So recall the Tilt is a bolt-on add-on light sheet system that could work on basically any inverted microscope. You can see on the right here, this is the sheet generator. This generates a sheet that comes in from the side of the sample and gets put over the objective. And on the left, we have our XY piezo Z stage that will hold the sample and scan the sample in Z through the sheet. As I said, the Tilt works with nearly any inverted microscope, laser system, or camera, so it's an easy add-on to an existing microscope system. What's nice is it also doesn't interfere with any of the modalities on the microscope. So you can easily add Tilt to a point scanning confocal, spinning disc confocal, super resolution system. It can add light sheet to basically any imaging workstation. You could use virtually any objective on the microscope, from 20x to image organism level imaging, up to 60 and 100x for looking at intracellular dynamics. It works with most imaging software, because the only thing that you're controlling on the light sheet side is the stage. And that's controlled to a standard MS2000 controller from ASI, which is supported by most software packages, or the piezo stage can be driven simply by an analog voltage. And the key feature of the Tilt is that there's very low bleaching and very low phototoxicity, which makes it ideally suited for doing long-term live cell imaging. Now recall, the way the Tilt works is we generate 4 sheets. These 4 sheets get focused with a cylindrical lens and come to a focus. The point where these 4 sheets focus is where you get an interference pattern, and that's where the imaging part of the sheet is. That gets positioned over the center of the objective, and your sample gets scanned through that. Now, in terms of sample chambers, there are 2 main considerations. One, since we'll be doing, or we can be doing, high resolution imaging, you want to make sure you're imaging through a good quality cover slip. Number 1.5 and as flat as possible. The second thing to consider is that the sheet is coming in from the side. So the side of the chamber can't interfere with the sheet. So that means it has to be optically flat. You cannot use round dishes with the Tilt. You cannot use a cover slip mounted onto a microscope slide. It has to be mounted into a dish with a flat input side for the sheet. Now, there's a couple commercially available options for this. Ibity makes a 4-well and an 8-well chamber. They have both a glass cover slip option and a polymer option for the imaging. You want to make sure you use the glass cover slip option, and the sides of these are typically flat enough not to have a significant impact on the sheet. Another company called Cellviz also makes 4 and 8-well chambers. The one caveat with the Cellviz chambers is that they're much shorter than other chambers. They're not the standard microscope slide length. To accommodate this, every Tilt ships with an adapter to allow you to use one of these Cellviz chambers. One also caveat with these Cellviz chambers is because of the nature and how they're produced. There's typically a pull mark on one side or the other. That pull looks like a small dimple. When it's there, it's very, very obvious. So you just want to make sure you avoid imaging through that section of the chamber. If you see that on one side, all you have to do is turn it around and image through the other, or image through another part of the well. In addition to the commercially available ones, we also supply imaging cuvettes, 12.5 or 21 millimeter diameter cuvettes. What's useful about these are very useful when you're imaging larger organisms, and something that you're going to have to mount and orient. So you could do that by mounting the sample right on the cover slip and then adding the chamber over top of it. And we'll go through later a little more on how to do that. You could also mold your own PDMS chamber. The PDMS has the refractive index of water, so it works very well in terms of imaging with the Tilt. Couple of considerations when you're molding your own chamber. One is that the side of the chamber that the sheet enters needs to be molded against a finely polished piece of metal. You're not going to be able to cut the side and get it flat enough not to disturb or interfere with the sheet. So you're going to have some sort of highly polished piece of metal for the input side to be molded against, so it's nice and flat. You don't want any obstructions between the sheet entrance and the sample. No flow chambers. You don't want to have any other components of your chamber between the input side and the sample. And all the channels, if you're creating channels, all the channels need to be straight. You don't want the sheet going through any curved surfaces. So here's a very simple, basic example of what you could do. In this case, the blue is the PDMS, and the whole chamber is molded and fused to a cover slip. In this case, there's an input and output port for perfusion, and then there's a small chamber molded in here, very thin chamber where you could flow in cells or organisms or what have you. So you're able to keep a constant perfusion going through, but still be able to image anywhere within this chamber. So it's a very simple example of how to do something like this. And the molds for these can be made, are very simple to make with 3D printing and are easily reusable. We also have temperature control options for the tilt. Because we're trying to do long-term imaging and we could image at high resolution in cells, we need to make sure we can keep the cells happy. So Onco Labs has made a custom incubation chamber for us. It has temperature control, heating and cooling options, CO2 control, humidity, and works with both their Bold and Uno line of controllers. There are three chambers that are offered. One chamber which is simply heating, a second chamber which has no heating or cooling at all. It's just for CO2 and humidity. You'd use this if your microscope is already sitting in some sort of plexiglass box and you're keeping the whole microscope or the whole stage area under temperature control. You could just then use the Onco chamber to maintain CO2 and humidity in a small area instead of having to maintain that through the entire chamber. And then there's also a jacketed version for doing both heating and cooling. This is not Peltier-based cooling. It works through a water bath-based system, so you're not going to do rapid temperature changes, but if you're trying to maintain a specific temperature below ambient, then this is a great way to do that. Well, let's talk a little bit about sample prep and how that works with the tilt. Now, one nice thing about the tilt is it doesn't really require any real specialized sample prep. Some of the other light sheet systems out there have some very specific requirements for sample prep, which makes it kind of difficult for certain types of samples to be imaged with. On the tilt, it's pretty straightforward. There's just a few considerations to keep in mind. One is that if you're imaging cells or even larger organisms, you want to keep the plating density relatively low. Because the sheet's coming in through the side, if you have a high density of cells between the cell you want to image and the input side, the sheet has to pass through multiple cells and potentially some debris. That has the potential of causing some striping in the sheet, which would cause some striping in your images. Striping is an issue pretty much with any light sheet system out there. Each system has their own ways in which they mitigate it. In our case, one of the best ways to mitigate it is just to keep your cell density rather low. If you're imaging cells, you want to image at somewhere around 30% confluency. For larger organisms, if you're putting multiple larger organisms in a well, you want to image them in this sort of orientation with the sheet coming in from the right. You want to image them in sort of a vertical orientation versus a horizontal orientation. In this case, on the bottom here, the sheet's coming in this way. The sample on the far left the sheet has to pass through multiple samples first, and again, that could cause the sheet to be distorted or striped. The part of the sheet that you're interested in, or the part of the sample you're interested in, you want to be oriented towards the light sheet. So if the sheet again is coming in from right to left in this sample, you want to have the part you're interested in on the right side versus on the left side. So in this case, the sheet has to pass through, this is supposed to be a fish embryo, will have to pass through the yolk sac, and that's going to pretty much absorb and pretty much destroy the sheet on you. So you want to have the sheet hitting the part you want to image first if at all possible. And one simple little thing, but you want to make sure there's enough media in your imaging chamber. If your mounting media is very low, the sheet's going to scatter off the meniscus and you're not going to get a good quality sheet, and your imaging is going to be degraded substantially. A couple other things to think about that are not normally thought about when you're imaging straight through the cover slip. One is that the media needs to be free of debris. And if necessary, just a syringe filtering works just fine. You could use OptiPrep, and we'll talk about that a little more in a minute, and that could significantly improve your imaging. And when imaging cells, just prior to imaging with the tilt, you want to make sure you rinse the wells out very well. That way, any dead cell and debris is going to get washed away and not potentially be there to interfere with the sheet. Talk a little bit about OptiPrep. One thing to remember is that the refractive index in the cytoplasm of most cells is greater than that of water. So as the sheet passes through a cell, the cell itself can act as a weak lens and can cause some distortions of the sheet. So one way to get around that, again, is to have a low plating density. That way the chances of it passing through a cell before it gets to your cell of interest is pretty low. Or you could add a little bit of OptiPrep. OptiPrep has a fairly high refractive index. It's also completely inert, so it's not going to interfere with the cell, the biology, or imaging. So if you add about 10% OptiPrep in your media, it raises the refractive index of your media to be much closer to that of your cells. And when the index of the media matches the index of the cells is no longer act as a lens, so you don't have that index change as the light's passing through it. Another benefit of OptiPrep is that when you're imaging thicker samples, it allows you to image deeper in the sample while minimizing spherical aberrations. Now, oftentimes samples can be rather mobile or they can float. So there's two basic ways that you could immobilize samples. One is using low melting point agarose, and the other is using a PEG-based hydrogel system. We'll talk a little bit about each of these now. When you're mobilizing through low melting point agarose, you want to keep it the low melt pretty much no more than 1%, and even 0.5% is usually going to be okay. Now you have to make sure you boil, when you're making the low melt, you have to boil it very well, at least 5 minutes. And that's to ensure that everything is in solution and no particulates are left in solution. Small particulates within the chamber or within the low melt can interfere with the sheet passing through it. Some people also go as far as syringe filtering the hot agarose prior to using it. The way you would use this is you'd put 1 or 2 microliters of low melting point agarose on a clean 22 by 40 cover slip, and I'm assuming that you're going to be using one of our imaging chambers in this case. You're going to add your sample in a very small drop next to that. What people often then do is use a chem wipe or a piece of lens paper to wick away most of the media they put down, leaving the sample. And then you'll very carefully push the drop of low melt onto the sample. You're going to let that dry for a few minutes. Then you're going to mount the cuvette over top of it, and then fill that with low melting point agarose. Again, because you don't want to interfere with the meniscus, you're going to fill that chamber at least halfway with low melting point agarose, let that harden, and then if you can be imaging long term, you're going to top that with buffer. That way the low melting point agarose doesn't dry out in long term imaging. Hydrogel is another nice way of immobilizing samples. It uses basically a 20% weight to volume solution of PEG, molecular weight 3500, and 0.1% weight to volume Igracure, which is a photo initiator. And this is a UV curing based setup. So you're going to cure your hydrogel with like 300 nanometer light, so usually like a transilluminator works just fine for something like this. And again, the same basic idea. You're going to add your sample to the cover slip in a small drop. You're going to mobilize that. And if you need to add drugs or chill down your sample to slow the mobility, say for live C. elegans, this is the time to do that. Then after it slows, you're going to add the cuvette on top of it. Very carefully add the hydrogel solution. Reorient the sample if it gets moved or disturbed. Then you're going to quickly cure it on the transilluminator, and you're good to go for at least an hour or more. If you're imaging longer than an hour or so, again, you're going to want to top off the top of that with either buffer or mineral oil to keep it from drying out. We've had good success using hydrogels to image adult C. elegans, and for anybody who's images C. elegans, you know how mobile they are. So this is a nice way of keeping them trapped, but the porosity of the hydrogel is such that buffer and medium food can still circulate around. So you can maintain them for a very long period of time. So that's about it for today. If you have any questions, you can always email me at sales@mizarimaging.com or visit our website, www.mizarimaging.com. And what I'm going to do for this particular movie is I'm actually going to make a PDF of these slides and post it up with the post, because there's a lot of information here that you may want to refer back to. Thanks a lot. Have a great day and happy imaging.